Hi everyone. In this video, we're just going to do a short and basic intro to limits. So we want to find the limit 4x squared plus 7 as x approaches 3, and we want to know how we can do this. So first off, not first off, the only thing we would do is basic direct substitution, meaning we would just plug 3 into x, meaning this would get us 4 times 3 squared plus 7. 3 squared, 9. 9 times 4, 36. 36 plus 7 would get us 43. And this would be the answer. So this is a basic limit problem right here, but we're going to do a few more as this will be a shorter video, so stay tuned. Let's work with this function now. Feel free to pause the video and attempt this yourself. Okay, so we could do direct substitution again by plugging in -2 into x. This would get us -2 squared plus 3 times -2 plus 4 all raised to the second power. Okay, and now we could just apply our basic math. -2 squared, 4. 3 times -2, -6, plus 4, all raised to the second power. 4 minus 6, -2. -2 plus 4 would get us just 2, and then it's raised to the second power, and then 2 squared gets us 4. And this will be our final answer right here. Let's work with a rational function now. So we notice that we can't plug in 2 now, since if we did that, we would get 0 over 0, which is an indeterminate form. So what we want to do is we want to factorize the numerator. Doing so, this gets us x plus 2 times x minus 2 over x minus 2. We then want to cancel the x minus 2's out in the numerator and denominator. This just gets us x plus 2. Plug in 2, 2 plus 2, then 2 plus 2 is 4. And this would be our final answer. So you will want to normally watch out for problems like these, as you could get an indeterminate form if you were to plug them in immediately. So try to simplify the function whichever way you can, if possible. So without any further ado, let's move on to the next problem. Let's work through another rational function here. Feel free to pause the video and attempt yourself. So what we want to do here is, we can't just plug in 1 into the function yet, as we would get an indeterminate form. So one thing we can do is we can multiply the numerator and denominator by square root of x plus 1. This would get us root x minus 1 times root x plus 1 over x minus 1 times root x plus 1. Okay, then what we will want to do from here is we will want to multiply them together. Well, we will want to multiply the numerator together only. That would just simply get us x minus 1 over x minus 1 times root x plus 1. Cancel the x minus 1's out. Then we would get 1 over root x plus 1. Now we could plug in 1. We would get 1 over 1 plus 1. And then we would get 1/2. And this is our final answer. I love rational functions. I hope you do too. So without any further ado, let's move on to our last problem. Let's work through this last function here. So we want to find the limit e to the x minus 1 over x as x approaches 0. So let's write out the function to make things a tad bit easier. Just looking at this function, we can't plug in 0 right away, as e to the 0 equals 1, and 1 minus 1 is 0, and we're evaluating the limit as x approaches 0, so that wouldn't work. So what we can do here is we could apply L'Hopital's rule. It's where we keep taking the derivative of the function until we no longer have an indeterminate form. So doing so, that would just simply get us e to the x over 1. And now we could plug in 0. E to the 0 equals 1, and our denominator is 1. So our final answer is just 1. I will be saving L'Hopital's rule for another video, but I just thought it would be cool to do it in this video as our last problem. But anyways, that's going to be all for this video. I really hope you enjoyed or learned something from it, and if you did, feel free to like, subscribe, and hit that bell. And please leave either positive or constructive feedback in the comments section for future improvements. That's going to be all from me, and I will see you in the next one, and happy holidays.